take a look at this problem that deals with an object being kicked at an angle and see how we deal with projectile motion here. A soccer ball is kicked with initial speed 18 meters per second at 35 degrees above the ground. How far horizontally does it travel? Let's begin by drawing a sketch that represents the object's initial conditions. So here we have 18 meters per second. There's a vector arrow for that velocity and an angle of 35 degrees. The object wouldn't actually travel in that direction. It would begin to fall away from that due to gravity, and so it would follow a projectile path, a parabolic path like is shown here. This then is the distance that we are trying to find. The horizontal distance, the x, down below. We're going to want to make sure that we break things down into components so that we have a portion, the portion of the velocity that points horizontal for the constant speed part of the motion, and the portion of the velocity that points vertical for the acceleration. We would use sine and cosine to find these two components using the cosine function here. 18 times cosine of 35 would give us 14.7 meters per second. And then using the sine function over here, we would get 10.3 meters per second. So along the horizontal direction, we can almost find x. We would need to know the velocity in the x direction, which we have, and we would need to know the time that the ball is in the air. That's where the problem comes in. So let's switch over and look at the vertical part of the motion. We want to notice how in this problem we don't know anything about distance. And so the equation x equals v sub o t plus at squared over 2, this equation is not going to be useful. We don't have enough information. But if we begin with v equals v sub o plus at, that's going to allow us to find the time and then use that in the horizontal part of the motion. Right. Remember that when an object leaves the ground, it returns back to the ground at the same speed. So if we launch it upwards at 10.3 meters per second, straight up, it would come back to us at 10.3 meters per second, but now pointed downward. And so we can set this up by saying that our initial velocity is positive 10.3, and our final velocity is negative 10.3. That will cover the entire motion of the problem, from the beginning to the end. Since the object is launched upward, we are considering upward positive. So when we put our acceleration in, we want to make sure we use negative 10 meters per second squared. Then we could do some algebra, collect our constant terms on one side, divide through by negative 10. We find that the time of flight is 2.06 seconds. Then we can use that time for the horizontal part of the motion and say that our horizontal distance is 14.7 meters per second times 2.06 seconds, or 30.3 meters.